Chapter 2.2 is multiplying matrices. We did adding and subtracting last class, or last video. Now we'll multiply. When multiplying matrices, the inner numbers of the dimensions must match up. Here's what I mean by that. This right now is a 1 by 2 matrix. This is a 2 by 3 matrix. Well, those are the dimensions. We can write the dimension like this. Since the middle numbers are the same, this can multiply. If the middle numbers are the same, you can multiply. If the inner numbers of the dimensions are the same, you can multiply. If they're not, you can't. So, suppose I had like, this is a 2 by 2, this is a 1 by 3. Well, a 2 by 2 cannot multiply a 1 by 3 because these two numbers aren't the same. And next is one of the most useful and worth hanging on to tricks about multiplying, or matrices in general, not just multiplying, but in general. If the inner numbers match up, you can multiply, but if you can multiply, the outer numbers tell you the dimension of the new matrix. So this is a 1 by 2, and you should be at the point now where you can see the size of these matrices pretty well. This is a 2 by 3. When I multiply this, the inner numbers match up. That means I can do it. That's good. So the new matrix will have dimension size 1 by 3. Because that's what these numbers here are saying. The outer numbers tell you the size of the new matrix. The new matrix will be a 1 by 3. Now, I've not yet shown you how to multiply. It's not like if you think you know how to do it, you've not seen it before, you don't. I've not yet shown you how to multiply, but first I want to show when you can and can't multiply. So here's 4 matrix product scenarios. Pause the video and determine which of these can and cannot be multiplied. Now that you've paused the video to see which of these can and cannot be multiplied, this is a 3 by 3 times a 2 by 3. This one can't be done because the inner numbers don't match up. This is a 2 by 2. This is a 2 by 3. The inner numbers do match up. This one's good. That one can be multiplied. This is a 3 by 3, sorry, 1 by 3, 3 by 1. The inner numbers match up, so it can multiply. And what I've not done so far is talk about the new matrix. The new matrix will be a 1 by 1. It's going to equal some 1 by 1 matrix because the outer numbers are 1 by 1. So over here, the outer numbers were 2 by 3. It would have given you a 2 by 3 matrix when you multiplied. And this is a 3 by 1 times a 1 by 3. It will be multiplied. It's able to be multiplied, so the new matrix will be a 3 by 3. Okay, hope that's clear. Next we'll talk about how to actually multiply. I'll go through the first example really slowly. You're going to want colors and highlighters if you're doing it on paper, and you want to be as clean as you can because it ends up, there's a lot of things sort of happening at first. Here's matrix A, here's matrix B. I'm going to do A times B. Multiplying, like everything else, goes row column. And I'm going to take this row and multiply it onto this column. I'm doing the row onto the column. Think about it like this row is turning onto this column. So what ends up happening is I'm going to switch back and forth between pen types a lot here, so be patient, please. 2 times 6 is 12. 1 times 1 is 1. Negative 3 times 6 is negative 18. And that will make up the first cell of my new matrix. So remember, this is a 2 by 3, and this is a 3 by 2. The inner numbers match, so the new matrix will be a 2 by 2. I just wrote mu, but ignore that. The mu matrix is going to be a 2 by 2. So here's the top left. This is the top left cell of this new matrix. Now, I'm going to erase all this. I'm going to do this row onto this column. Row onto column. So this goes 2 times 2 is 4. 1 times 3 is 3. Negative 3 times negative 4 is positive 12, and I'm adding all those things up. So I've not yet actually finished. Like when I'm all said and done, there'll just be single numbers in these spots. But right now I'm just kind of showing how to set up each slot. Row onto column, row onto column. I just did top row left column and top row right column. Now I'll do bottom row left column. And don't worry, I'll do a bunch of examples of this. 4 times 6 is 24. 0 times 1 is 0. 5 times 6 is 30. That's going to be the bottom left cell. Last one. Row onto column. 4 times 2 is 8. 0 times 3 is 0. 5 times negative 4 is negative 20. Now I'm going to add up all these numbers. So my top left cell is 12 plus 1 is 13, minus 18 is negative 5. My top right cell is 4 plus 3 is 7, plus 12 is 19. That was this one here. Bottom left is going to be 54. Bottom right is negative 12. There is my multiplied matrix. Matrix A times matrix B, row onto column. So to kind of recap that before I do a bunch more examples, I took this row and took each individual cell and kind of twisted them to match up with that column's cells. And they multiply and they add. And you might wonder, like, well, why? Why multiply, add? Where does that come from? The kind of the point of this matrix multiplication is to make specific types of problems easier. And as I do a problem at the end of this video, you'll see why that's useful. So this is the part where if you feel like you're okay with multiplying, you can maybe fast forward. Do what you need, watch as much as you need to kind of figure it out. But I'm gonna multiply. This is a 2 by 2 times a 2 by 3. So the new matrix will be a 2 by 3. I knew that because the outer numbers were 2 and 3. The inner numbers matched, so I can multiply. So my new matrix is going to look like this. 1, 2 rows, 3 columns. The question becomes, what goes in those spots? So I'll move all this over here, and I'll do some row column action. Row column. Try and keep my colors consistent. So this is going to become 6 minus 4, which is going to become positive 2. Next I'll do row under this column, and that becomes 9 plus 0, which is 9. Then I'll do row onto this column. It's getting so dark you can't see it very well. But this row onto this column becomes negative 3 plus 10, which is 7. And if we were in person, and you could see me doing this without having to do the magic pen video thing, you would see me touching cells with my fingers over and over, just touching with both hands. Maybe I should actually put a video on of me doing that, but I'm not going to. But using colors and touching with your fingers can be very helpful. This can kind of make your head hurt at the first time you do it, and that's a good kind of hurt. Now I'll do this row onto these 3 columns. Four times 2 is 8. Negative 2 times negative 4 is also 8. 8 plus 8 is 16. Negative 2 times 3 is negative 6. I'm sorry, I did that backwards. 4 times 3 is 12. Negative 2 times 0 is 0. 12 plus 0 is 12. 4 times negative 1 is negative 4. Negative 2 times 10 is negative 20. Those add to negative 24. Eventually you will find you can do this faster if you don't write out everything and just do the arithmetic in your head and write down the cells. That'll make it go much faster. I'm going to move on a little bit quicker now. This is a 2 by 3. This is a 2 by 2. That can't be done. The inner numbers don't match. Those are our favorite problems. This is a 1 by 3. This is a 3 by 1. The inner numbers do match. The outer numbers give us a 1 by 1. So this is going to come out to a 1 by 1 matrix. That's just a single number. It's going to come out to a single number matrix, and that's fine. I'm doing row onto column, and that's it. So it's going to be 1 times 6 is 6, 2 times 0 is 0, 4 times 7 is 28. This is just going to be the matrix 34. I missed the 8 here, 28. This one, however, is a 3 by 1 times a 1 by 3. The new matrix will be a 3 by 3. I find it very helpful to write out the slots and try and do that as non-ugly as possible, which isn't always my strength. I'm going to do this quickly. Row, column, 6, row, column, 12, row, column, 24. I know that feels weird, like there's not really rows and there's not really columns, but we have to still think of it like there's rows and columns. Row, column, 0, row, column, 0, row, column, 0. Row, column, 7, 14, 28. Okay, now this is a 3 by 3 multiplication that I will start by going through slowly, but kind of pick up pace as we move. Once you can understand this one, all the ones that follow sort of make sense, or at least they become easier, I think. The inner numbers match, which means we can multiply. The outer numbers are 3 by 3, so our new matrix is going to be a 3 by 3 matrix. And I think it's really, really helpful to give yourself slots to shoot for. My 3 by 3 matrix will fill up these slots. Now, one way you can go about thinking of this is which row and which column are you doing? Like if I did top row times the left column, that would go into the top left slot. And if I did top row times middle column, that would go top middle. And this would be top right, bottom left, bottom middle, bottom right, sorry, middle left, middle, middle, middle right. So like if I did the middle row times the middle column, that result would go there. And this would be bottom left, bottom middle, bottom right. So you can always think of it that way. That can sort of give you a clue as to where the arithmetic you're about to accomplish is going to get stored and what cell. So I'm going to start by doing top left. I'm turning the top row onto the left column. Well, 5 times 1 is 5. 1 times 3 is 3. 2 times 2 is 4. I add those up and I get 12. The top left cell is just 12. So these matrix products will always have single numbers in their cells. Not some arithmetic, not some expression, just a single value. So now I'll do top right. No, I'm sorry, that was top middle. I'm a very good counter. Top middle. 5 times 4 is 20. 1 times negative 1 is negative 1. 2 times 0 is 0. I add those up, I get 19. Top middle. Now I'm going to go top right. 5 times 0 is 0. 1 times negative 1 is negative 1. 2 times 10 is 20. Negative 1 plus 20 is 19 also. There is my top right, top middle, and top left. I just did the top row. Now I'll do the middle row onto the other columns. So I'm going to go middle, left, which is going to be 0 times 1 is 0, 3 times 3 is 9, negative 1 times 2 is negative 2, and that gets me a 7. Middle, middle, 0 minus 3 plus 0 is just negative 3. You should hopefully get to the point to where you don't need to write everything down. Writing it down will slow you down, and it can kind of give you a chance to make more mistakes. If you can't do the mental math, then that's fine. Write it down. There's no issue with that. But you should maybe work towards being able to just go like 0 times 4 is 0, 3 times negative 1 is negative 3, Negative 1 times 0 is 0. Well, there's two zeros there, so this is just going to come out to this negative 3. And if you were in class watching me, you would see me touching cells with both fingers as I go. And the touching of the cells with both fingers I find very helpful. This came out to a negative 3. So now we're going to do this row to this column, 0 minus 3 minus 10. That is negative 13. Now it's bottom row, bottom column. I'll go with this pretty pink, but I gotta grab my highlighter and show it also. Here's a nice little purple. Let's see if I can get that pretty pink also here. Row, column, row, column, row, column. That's what's happening here. So 2 times 1 is 2, 0 times 3 is 0, negative 2 times 2 is negative 4, 2 plus 0 minus 4 is negative 2. 8, 0, 0, that's just 8. 0, 0, negative 20, that's negative 20. I know I did these last ones kind of quickly, but we don't want to spend forever talking through this. There is a 3 by 3 multiplication. Okay, one of the reasons this is useful, so matrices are like one of the most used things in the world these days because computers and phones are kind of just big matrix machines. Like whenever you're running a program on your calculator, it's probably incorporating some form of a matrix somewhere. I said calculator, but I really meant computer or phone. And that's why that movie, The Matrix, is called The Matrix, because they live in a computer, and the computer is just a big matrix machine. So let's pretend like you own 2 hotels, and the following table shows how many luxury and how many standard rooms are available at a given hotel. And we'll note briefly that you're really bad at naming hotels, because no one's going to go stay at Hotel A or Hotel 2. But anyways, here we go. Hotel A has 6 luxury rooms, 18 standard rooms. Hotel 2 has 9 luxury rooms and 12 standard rooms. These are also really small hotels. Let's move on. Luxury rooms cost $180 per night, and standard rooms cost $65 per night. How much money can each hotel make when fully occupied? Well, I can set up a matrix of the data here. 6, 18, 9, 12. And I want to multiply the rooms by their cost. So if over here, this is a 2 by 2 matrix. So I want to multiply it, and I'll make this a 1 by 2. And I made it a 1 by 2 so that the middle numbers would match. That was the key. I had to make the middle numbers match, but I could put a 180 here and a 65 here. Now when I multiply these, and I have to kind of think ahead about how the row-column action works, I'm going to go row onto column, and you can barely see that, but row onto column, and it would do 180 times 6, which is the number of luxury rooms times their cost, and then it would do 18 times 65, which is the number of standard rooms times their cost, and that would give me, then I add those two up, and I get the total cost that I would be, or the total income I would be getting from Hotel A. Do it again for Hotel B. It's a very clean and useful way to do some basic arithmetic, and you can see hopefully how useful this would be if you're doing lots of hotels with lots of types of rooms for a whole company. They'll have maybe tens of hundreds or, I don't know, just dozens of entries. Now, there is a way to do all this matrix stuff by calculator, and I will show it to you eventually. But for now, we're just going to stick with doing it by hand like we have been. I'm going to say by hand. I mean, I got to do 180 times 6, and I'm just going to multiply that here to make sure I get it right. 180 times 6 is 1080. And then 65 times 18 is 1170. I add those up, 1080 plus 1170. Come on. Holy cow. Is that going to work? Yeah. That's $22.50. That's how much we're making in Hotel A. Now I'll do this row times this column, 180 times 9, plus 65 times 12. That's how much we're making in Hotel B. And you'll notice that this was going to be a 2 by 2 and then a 1 by 2 on the outside. So the new matrix should be a 1 by 2, so I should technically write it like this. 2250, 2400. That is what this product yields. So to recap this, matrices can multiply only if the inner numbers of the dimensions are the same. The outer numbers are the dimensions of the outer numbers of the dimensions tell you the size of the new product matrix. When multiplying, turn rows onto columns. And then here's two things I didn't actually discuss in this video. The order in which you multiply matters. So if we go back to this slide here, you'll notice, where'd it go? This one. These matrices are inverted. 1, 2, 4, 6, 0, 7, 6, 0, 7, 1, 2, 4. But when I multiplied, think of this as A times B and this is B times A. I did not get the same thing. The order in which you multiply really, really matters. A times B is not the same as B times A. Another thing of note is that there's no such thing as division of matrices. We'll talk about how to kind of get around division in our next video. But thanks for watching. Have a wonderful day. Hey, thanks for watching. I hope that was helpful. If you have any questions, leave them in the comments down below. There can be questions about the video you saw here or anything else in math I'm happy to help with. Subscribe if you'd like to watch more videos or see other updates as they come. I'm going to try to run through all of Algebra 2 Trig and then eventually hit more classes like Algebra 1 and Geometry and Pre-Calc and everything else. If you have questions about stuff covered that's not in this video, still let me know. I'm happy to help. And finally, if you're not one of my students taking the class, but you found the video and are watching it, or maybe you're a teacher and are watching it, you can buy the curriculum and buy the worksheets to go through it. That's found at the website listed down below also. So again, thanks for watching. Have a wonderful day.